Just a second. Yeah. So what is that? Like before understanding blockchain, I want to like give you some examples in the existing systems. Plus, what are the different kind of existing systems that are in the backbone of the blockchain, so that we will understand it better. Blockchain is not a particular software technology. It's a concept that is built on the top of other technologies. Okay. So to understand the blockchain, let's first discuss about these topics. Like there are two type of software architectures: peer-to-peer systems. I think you already know something about peer-to-peer system. We will discuss about it. Mixing centralized and distributed systems, and what is the exact purpose of blockchain. So once we understand these things, I think it will be a better, like we will be in a better position to see what it is exactly. Okay. Let's see. So I think you are very much aware about distributed and centralized system. It is a centralized system is a client server system where the server sits logically in between of all the clients. No client is allowed to directly talk to each other. And in distributed system, any client will talk to each other. There is no any centralized server. Are you getting the point?
Yep.
Okay. So I'm just telling you that these kind of two software architectures, because blockchain is somewhat related to the distributed systems. And if our software architecture is centralized, then what are the problems and how it is resolved by using the distributed system. Okay, let's see. What are the advantages of distributed system? We are not discussing about the advantages of centralized system, because all the banking systems are centralized very well. Every data, everything is stored on a centralized server and everything is controlled by a central authority. We are discussing about the distributed system advantages. So number one is we get high computing power, because in distributed system all the individual computers are connected together and they turns to a high computing power. I think you can understand it. Yeah. Cost reduction means like if we are getting a very big supercomputer to do a lot of tasks, it will be very costly. But if we start with 2 or 3 systems that are connected in a distributed environment, then the cost will be comparatively low, and increasingly as per the demand, we can increase the number of nodes or systems in the network. So if we need more demand in the computing power, we can add, and if we are not using any computing power, we can remove. So distributed system is a kind of flexibility, where our cost is reduced, and based on the demand we can like switch to higher systems or lower systems. So in terms of the cost reduction, it helps in that. The third thing is that higher reliability in terms of uptime. Means if a single computer goes down, then the other computers can take up the workload. But if a central system, a server goes down, generally it doesn't goes down, but it can be, then the whole system will break down, because everything is dependent on the central system. So in terms of advantage, distributed system provides this facility also. Also, we can grow naturally, means whenever a new computer joins the network, the system grows. So if there are 100 computers in the network, it is there. If there are 1 million computers in the network, it is there. So based on the requirement, the network grows naturally. Okay, it's like that. So in distributed system, we see there are these kind of advantages, but of course there are serious disadvantages also in distributed systems. That's why it is very difficult to manage those. Let's see. One biggest disadvantage is coordination. It's a really very big overhead for the coordination, because each and every distributed system is independent. You don't have the control on it, what it should do and what it should do not. And if any individual system doesn't work as per the requirement, then we can do nothing much about it. Okay. Other thing is the communication overhead. It is not very easy to communicate to systems that are located on different locations, because it is a distributed system. The individual computers are located on different locations, and there is no any central authority that is responsible for all these things. The third point is everything is dependent on the network. If the network is not there, it will not work. So network means the internet system or the intranet within the company must be there. Without it, it will not work at all. So network, it depends on the network highly. Fourth is higher program complexity. To manage all these things, coordination, communication, the underlying software that is written to manage all these things is comparatively very complex. Also, in terms of security, if there is a security issue, because we need to implement higher level of security in terms of the distributed system, because any system can connect, we are having very little control that what kind of softwares, antiviruses, patches, or any kind of security like firewall, antivirus, all these things are installed, not installed, updated or not. These kind of issues are there. So it is complex. The last point is security and reliability issue. Security, I have already told you that we are not very much sure that how much a particular system is secure. Suppose we are processing our data on a particular system, okay, and that system is a part of our network. It is very difficult to assess the security patches, antivirus, firewall that is there on the system. And if the firewall and security antivirus is not there on the system, there is high chance of data leakage and data theft. Okay, so there is also a big problem of the distributed system. Reliability issue is also a problem. It is not reliable. Suppose any system goes down, then what we will do? It is like if it is a small system, they can, like, the electricity power issue can be there, the system can be crashed, or there are a number of problems. So reliability is a issue also. So in distributed system, there are certain advantages but certain disadvantages. What if there is a technology or there is any complex system that can remove all these disadvantages? Then what we will get? Only the advantages of the distributed system plus the advantages of the central system that we will discuss later. So these are the problems. Okay, next, it is a peer-to-peer distributed system. Like every computer is connected to each other and they are sharing the data. Like I think you might have used some like BitTorrent, music sharing system, Napster. These kind of solutions are not having any central server. The computers are connected with each other and the data is shared amongst the computers only. There is not a single server through which data is being shared. So these kind of applications are there very much on the Android marketplace as well and on internet as well. If you notice, you will see these kind of applications. Okay, have you any do you have any query?
Good. So far, so good.
Okay. Okay, what we can do is we can mix centralized and distributed system to take the benefit of these two. On the left side, you can see that there is a network that in which every node is connected to different nodes. Okay, so and it is a peer-to-peer distributed system. On the right side, you see, although here or every node is connected to each other, but we have created a circle in between such that the servers that are connected in between in a circle are peer-to-peer, but the servers or nodes that are outside of that circle are connected in the central kind of system, in which the the servers within the circle plays the role of a central system. So this kind of mixed centralized and distributed systems are also there very much in the market. Like if you see, many companies are having multiple servers on different locations. If any server goes down, other server can take up, but the outside machines are not aware that in the back end there is a single server that is serving our content to us, or there are multiple servers. So that kind of application or the system is a mixed system, and the advantage is that at a level we get the benefits of these two systems together. Okay, so I'm just explaining you all this because blockchain is using these kind of technologies somewhere. Okay, next, move forward. Now, why blockchain? Now the question arises, we have discussed all 3-4 terminologies. What is the need of blockchain? Why blockchain? If we want to understand what is a blockchain, we need to first understand why it is needed. When there are multiple technologies, we have understood already the distributed system, centralized system, why there is a need of blockchain. For any kind of technology or any kind of invention, there is a generally, or like there is a problem. That's why somebody has thought about it to resolve that problem, and he has invented something new. So blockchain is not an exception. Somebody has understood or like seen there is a problem in the central system. There is a big problem, we will discuss in the next slides, and due to those problems, the particular person that is called Satoshi Nakamoto, who has invented Bitcoin. We will discuss later what is Bitcoin and something, but Bitcoin is the basically a cryptocurrency that is running on blockchain network only. So Bitcoin is the first application in the market that uses the blockchain technology. So why Bitcoin was invented? What is the basic reason? To understand that problem that was catered using Bitcoin and blockchain, let's take an example of a banking system. I think you told me that you are in the same field. I think you will better understand it, and might be you can give some inputs to me as well about it, like are there the real problems or not, and what are more problems. We will discuss those. Okay, let's discuss about the current banking system, or like you can say the banking system which is using the central management protocol for serving its customers. Okay, a bank generally maintains a central database that is called a ledger of each and individual customer. Whenever a customer logs in online to a particular bank, the data is fetched from a central computer that is owned by the bank. Okay, they store your account numbers, balances, the transactions done, and lot of other things. Of course, because they are providing these kind of services to the customer, they will take a minimal charge from the customer by various financial products. Whenever you interact, suppose any customer is interacting with your account, with his account, what he will do? He will generally do withdrawal of money using the ATM or transfer of money, online banking or NEFT or any kind of stuff like that. So what the bank will do? Bank will update the transaction in the ledger. If there is NEFT, then it will first debit and then send a instruction to another bank that it has been a transaction, please update in your records. So it's like that. Only the bank has access to the ledger. The customer and the bank, only these two parties can access the ledger. The customer can access his ledger or account on account only, not any other account that is there in the bank. Bank can access all the accounts that are there in the bank. Suppose at any point of time, bank decides to make a change, any kind of change in the customer's account, like imposing any bank charge or any kind of withdrawal of money or any kind of transferring the fund due to any government regulation to another fixed deposit or something like that. Customer can do not much about it. Although customer should be informed, there is a guideline of the bank or of the government. They need to follow those guidelines, but banks always try to impose some charges, some kind of stuff to earn money, because those are also doing the business. They are having the central authority, plus they can also use the account details to do marketing of their other financial products. Who can stop them from doing this? So this is the challenge. Are you getting the point? Now these are the problems. Bank takes days to clear overseas transactions. Suppose there are transactions between two countries, it takes some days. Nowadays it takes very less time, but if we talk about 2 or 3 years back, it was taking 3 to 4 days. Bank takes high transaction charges. Bank focuses to maintain minimum account balance. Bank always say that you should have this particular account balance, otherwise there will be a penalty or like that. Banks can misuse our funds. They generally don't do that, but we can do nothing much if they want to do like that. Banks never disclose what they are doing with our funds. Suppose we have deposited some cash or something in our account, then bank obviously will not keep that with them. They will lend that money to somewhere else, but we never know to whom our money is lended. Banks have the central control on that. They will never disclose that your money is given to this person. Also, it is not practical as well. Okay, if they wish to disclose, then also they cannot disclose. So other thing, bank have central control on our accounts, and we can do not much if they do any changes, any charges, anything. Also they can use our personal data to sell their financial products, like they can call you, like to take our credit card, take our insurance scheme, take a loan, like that. So like, because bank has all your data and you are a customer of bank, so they can use you. It's like that, because it is a central system. I think you agree with me to many of the points that are there here as a disadvantage of using a central system. What is your view? Can you tell me something?
No. Yeah, I understood these points. Yeah, because these are all very authentic. I mean, these are all good. It's not like if there is nothing harming here except one point, bank can charge more. But that is also, it's only if you are not. But these are all good points. I mean, these are all good things bank is doing. for safety for us. Right?
Yes,
And
correct.
banks are not like private things, like they are also really monitored by the upper
Yes,
federal bank,
yes,
right? So these are all
yes.
good things. So let's see how blockchain makes a difference.
Yeah, yeah.
Yes.
But suppose that is not monitored by something, or the monitoring is not very tight, then the banks try to do all these things that I have pointed out here. Agreed?
Yeah, yeah, right. Yeah.
Yeah, okay. Now, suppose let's take imagine like hacker gained access to the database. There is a central database. Somehow hacker gained access. You might have heard there are a lot of news comes around like some hacked the database of the bank. A lot of millions of money has been transferred to other network or to banks. It happens nowadays. Okay, so why it happens? Because if a hacker gains access to a central system, he has access to everything. If suppose everything is distributed across the world, across the globe, then how much hacking he can do? If he hacks a particular system on a distributed network, then he might gain some some kind of balance out of it, but not all, not everything. So suppose hacker has hacked, you can see on the right side, hacker has done control on the ledger that is centralized by the bank, and he somehow changes the transaction details. Somehow banks can restore the data, but it is ultimately controlled by a central entity, the bank. You need to request the bank that please restore. Suppose bank is not able to restore, then what you will do? You can do, actually everybody is dependent on the bank's capability. Suppose bank is not that much capable, bank is not very much investing on the security policies, bank is not updated with the latest standards to protect them against the security leaks, then might be all the banks are generally doing everything that they can do, but ultimately we are dependent on them. In that kind of scenario, all our money is at stake if the banks are not very serious in implementing the security things. Suppose there is a distributed ledger. What is a distributed ledger? I will see and discuss more in the next slide, but what is exactly it is, that particular ledger that is there controlled by a single bank. Over here in the right side in the image I have put a cross. Suppose this ledger is replicated over every customer of the bank. Let's say there might be some problems with that, how like how we can distribute the ledger to everybody, like that there might be multiple questions, but right now let's forget all those things, but take a scenario that suppose the ledger, it is stored in everybody's computer, that is the customer of the bank. Somehow on the system, let's say show this, no, distributed, okay, somehow let me show you this. Yeah, suppose there is a customer here, there is a customer here, there are around 5 customers over this network. You are seeing this? The ledger is not stored on a central system. There is no any central system over here. The ledger that is having all the data of all the customers is replicated on each and every computer. Okay, you see there is a yellow box with everybody. So what happens, suppose this buyer on the left side, the ID of the buyer is 5555, wants to send some money to this seller. On the right side 6666, he want to send some money over here. What he will do is he will make a transaction and he will announce that I have made a transaction, this particular transaction, this is the money, and I am sending this particular money to this particular person. And he creates a transaction and sends that transaction details to everybody that is connected to him in the network. Suppose all these three persons, I think you can see there is a block from the left side is moving to the right side. All these three persons get the details of these transactions. Okay, that particular transaction. Those three persons will validate the transaction. What kind of validation they will do? Either that particular buyer has that much money or not that he is transferring. Okay. These kind of the amount is valid or not, it is negative or not, like that. The account he is transferring to exist in the network or not. All these kind of transactions, suppose validations they do, and after that they have done the validation. They say, okay, this transaction is valid. That amount can be transferred. After this, the amount is transferred, and that particular amount transaction is updated in the ledger copy of each and every computer. There are 5 copies of the ledger. Every ledger copy is an exact replica, and every copy has all the transactions. Getting the point? Okay.
Yeah.
Yeah.
So one question here. One question. Yeah. So buyer 555 sends make a transaction first to 666, right?
Yeah, correct.
And it goes. The copy will go to everyone, even to 666 also, and he will have one copy.
666 also. Yeah, correct.
Okay. And 55 also will have. So everyone will have a copy of that. What transaction they did, like what is the balance now? What is so this the ledger there in centralized system, there is only one database, and there in that ledger they have each account like buyer account holder based transaction was updated. But here, yeah, that's why I may get in further discussion maybe. Like here, the whole ledger whole ledger database copy is going to each one.
No, whole ledger for this transaction is not going. For this transaction, only that transaction is going, but they have synced in the past time, they have synced it. At this moment, all the ledger is not going because the size of data is very huge. It can't go. And what they does, they first sync on whenever a new person joins the network, they syncs the data. It takes around 2 to 3 days. The latest data is first synced to his computer. After that, he is able to do the transactions. Okay.
Sync basically, not sending.
Yeah,
it
syncs. It syncs. Yeah, correct. Okay. There are a lot of doubts actually. I understand how that we can allow to have a local copy. What is the security? These things will be discussed, and all these things are taken care of. But first understand that the problem of distribution, like problem of hacking, that is being done by that hacker, how it is resolved, that we are discussing like that. Okay, now, so it is a problem in current banking system. Now we have tried to resolve the problem by the distributed system. I have discussed how the distributed system is working. Now what is blockchain? To resolve the issues associated with the centralized ledger, blockchain recommends maintaining the transactions copy at every user's computer, which will make the ledger distributed. That we have already discussed. Okay, what the problem will be resolved? We will discuss. All transactions will be maintained in a sequential manner. Sequential manner means in the transaction which comes first will be stored first. The transactions that are coming later will be then after that. So it will be a sequence based on a time. bunch of transactions are put in a block. Like you see, suppose there is a traditional system in which we are storing the data only in the ledgers. Before 20 years, when there were no computers, or 30 years back, banks were updating everything on the ledger, on a physical ledger. Getting the point?
Yeah.
Okay. So at that time, what they were doing, set of transactions were being filled on a particular page. When the page is filled, they turn the page, then they put the transactions on another page. So the transactions that are coming in a particular sequence, they are maintaining a daily ledger. Everything is being written first in the daily ledger, and after that those transactions goes in the relevant ledgers from that. So a daily ledger is first created, and then transactions are moved to the corresponding ledgers. Suppose that kind of same thing we are doing, but here we are doing using computers. The transactions, bunch of transactions are put in a block, like we were putting in a book, on a page, and it is that block, particular block is given a hash ID, like a page number. Okay, then what we are doing, we are putting around 50, 60 or 100 transactions on a particular block, and each block is giving a unique hash ID that is unique across the network. Then it will form a chain of blocks, like there will be multiple blocks of transactions will be created. Each block will be connected to another block. Why? How it will be connected? Whenever a new block is created, that new block will also store the ID of hash ID of the previous block. So whenever a new block is created, suppose 50 transactions are over, a new block will be created, and that block will be part of the chain, blockchain, and that particular new block will have the hash ID of the previous block. So each and every transaction becomes the part of a block, and block has a hash ID, and whenever a new block is created, that particular new block has the hash ID of the previous block. Now there is a question, what about the first block? That particular first block is a special kind of block that is having the hash ID 0, and that is called a special name that I will tell you later. That name we will discuss what is it is called. So it is basically blockchain. So how it resolves the problem, we will discuss. Now, how blockchain works. In blockchain, first of all, the dependency on the third party is removed. The central third party is no longer required, because everybody is copying the data with his own system, on his own system, and there is a protocol or there is a set of software that does all the updates in these all the ledger copies somehow. So there is no need of a central authority who is responsible for updating the balances and updating the security and everything. Everything is being done by a software that works behind the scenes. Okay, that security that particular algorithm that is written, that works under the blockchain. Blockchain that we have discussed is a connected link of particular blocks, that is the data, and the software that works on that chain is the blockchain software. So that software we will discuss later, but that software is capable enough to maintain the security, do not allow hacker to hack anything, do not allow any user to hack any kind of each other's data. It doesn't even allow to send the money 2 times. Suppose they, like it is a digital system, they can use Control C and Control V, create multiple copies of the money and then send it. Blockchain software also blocks it. It doesn't allow these kind of things. We will discuss how it does. So people in the same network, they are connected, like whoever thinks that central system is not good there should be a decentralized system. All those people who are having this kind of mindset connects with the network. That network, in that network, every person has a network ID. That is a unique, very big network ID, and everybody knows each other only by ID. Nobody knows the name of anybody. Like on the image you say every person has a ID. Buyer has 5555 ID, seller has this ID, Amit has this ID. So this particular name of Amit, Akshay, Rajni, these names are not stored in the blockchain network. These are never stored. Only the ID is stored. That is called a network ID. So in terms of privacy security, like if somebody knows that my name, then he can pretty obvious know my balance, and nobody should know how much money I am owning. So that kind of privacy is there by the way of having the ID. Blockchain doesn't store any kind of name. Basically there is no any KYC system that takes the ID proof, address proof, name, nothing it requires. It doesn't. What it requires, just a ID. Go to the blockchain system, say that I want to work with you, and create your ID. A particular ID will be created. You don't need to reveal your original information. You can put any kind of dummy name that it is my name. There is no any verification done on that. So this kind of like ideology works behind the blockchain. The thing, one thing is that, another thing, every user in the network have a copy of the ledger. So if any user has the ledger copy, he don't know anybody's name. Only everything is stored in terms of ID. So in terms of privacy leakage issue, there is no kind of leakage because nobody knows each other's name or any kind of personal information. We will see these things later on in much detail, but for the sake of understanding, one thing I was just clear to you, that personal information is not stored over there. Whenever any transaction happens, it will get added to every copy of the ledger. Like you can see in the network, whenever a transaction is happening, that transaction is like announced in the network that I am doing this transaction, please validate it. Once the transaction is validated, that transaction becomes the part of the blockchain. Once the transaction has become the part of the blockchain, there is no power in the world that can remove the transaction from the blockchain. No any circumstance, no any condition. If it is written, then it is written. That's it. No, even the government, supreme government, the highest authority, anybody in the world cannot remove anything from that particular blockchain. Okay, even the owner who has done the transaction cannot remove it. So this kind of stuff is done, how the blockchain works. Let's see further. Okay, let's assume there is a like hypothetical scenario. Let's say we have 5 users in a network, and assume that a buyer and a seller have joined a network to do a fund transfer. Okay, the buyer is 5555, seller is 6666. Buyer wants to transfer a fund to the seller, so he will create a block or a transaction, and he will put a name. It is the buyer, the seller name, and the amount. Whenever he put a name and the seller name and the amount, that particular name is converted automatically to the ID, or he will put only the ID, not the name. Generally he put only the ID because he don't know the name of the buyer. The name is the fake name, and it is called pseudonym. So it is not a real name, it can be any name. Whenever the transaction travels in the network, that name is replaced by the ID, whatever it is, and that particular transaction, that is I am showing in the right side in the bottom, travels from the network, from the buyer to the seller. It's like that. the transaction will be broadcasted and the user can see only the network ID, not the name of the user. Okay? Okay. Next.
Yeah.
So it is the like in the big form I have created the it again. It is the same image that I was showing in the previous slide. I think you can understand it. Okay, I'm moving forward. Okay, now what will happen? The user will validate the transaction by checking the balance of the buyer account. The other users in the network, suppose there are 50 users who are validating it. Every user says that the balance is $50. Okay. To say the same thing is possible only if they are telling the truth. To tell the same lie by everybody is not possible. I think you can get me, because they don't know each other. A person will say it is $55, the person will say $65, the other person will say $75 is the balance. Then it will be like identified very easily, because it is a lie. If everybody is telling the truth that it is a $50, $50, $50, if everybody is saying the same thing, then it means it is the exact truth and we can take it. So it works on the same ideology. Every system, every user in the network validates the transaction, checks the balance and all the other things. And if every user is saying that yes, I have validated everything and it is okay, then the fund will be transferred and it will be approved. Let's say it's just a kind of voting system. In any democracy, suppose out of 100 users, 95 users are saying that it is valid, then it is valid. The 5 users who are saying that it is not valid, either they are telling the lie or there is something bad with them, might be. So it is a kind of voting system. Everybody is saying valid, then it is valid. That's it. After that, the transaction is approved. The transaction becomes the part of the blockchain and the ledger is updated. The ledger copy at each system will be updated. There is no any central authority. Suppose here the hacker comes, he has hacked the system. He has done any changes. Okay. Now, whenever a new transaction will occur, might be this particular user will say something different and all the other users will say something different. Might be this users will say that this balance is like this, or there will be some new transactions added to the ledger of this user. Something will be different. The chain will be different. These users' chain are identical. The other users have the identical chain. Means, suppose a transaction hacks this system after 1 hour or 2 hours, all the other users will realize that the user of this particular, the blockchain of this particular user, which is having the ID 1111, is different. So what the user will say? User will say, okay, your copy is different. Might be there is something bad either with you or either with me. Okay, because two copies cannot be different. Either your copy is bad or my copy is bad. Then what they will do? They will cross check their copy with other users, that see, this is my copy, is it okay? The other users will either say it is okay or not okay. So based on the majority, what will happen? They will know that this particular copy is bad. When they will know that this particular copy is bad of the user 1111, the copy will again be synced from the other users and the changes done by the hacker will no longer there and it will be immediately rejected. These kind of things, stuff is done like within 5 minutes, 10 minutes. Within 5 minutes, the system will know that the copy of this particular user has been changed by someone. Might be that particular user himself is a hacker. A hacker has joined the network. He himself is a hacker. He synced the copy, then added some blocks of transactions saying that he is having this kind of money and this kind of thing in the network, and then he say, okay, see, this is my ledger copy, please accept this. Nobody will accept, because they will say, see, your copy is very much different from me, let's check with others. The copy will be different from everybody, then how it will be accepted? It will not be accepted, because here the voting is done. It will not be accepted, it will be immediately rejected. Only way to hack the system is to hack all the local ledgers at a single time of all the users and do the similar changes in each and every copy. And the way the blockchain software is written to do this kind of stuff, to hack every database and to change the data everywhere, at least they have to hack 51% computers. Like there are 100 computers in the network, the hacker need to hack 51 computers, because only the majority will be there after 51 computers or 51% computers are hacked. And a network have thousands of computers, so the hacker need to hack thousands of databases together, otherwise it will be failed. And it is almost impossible to hack all the copies and to change the data, because to change a single transaction and to hack a single transaction in the network, only a single transaction, takes around 4 years. Are you getting my point? If anybody wants to change a single transaction, the system is written in such a way, suppose you want to change $10 to $1,000, after that change is done, to validate and all the things, around 4 years will take. So it is impossible to do this kind of 4 years wait and do the changes in each and every copy. We will see these details later, how the 4 years will be taken, but the algorithm is written in such a way that this kind of change is impossible. Any query?
Yes, okay. Good.
Yeah. Okay, now suppose, now there is the C. See, on the left side I have put a message box. Since my ledger copy is not matching with other users, my ledger copy seems to be hacked, let me take it from nearby users. It means it will again take a copy, it will sync the copy, its copy will be rejected, and it will sync the copy again, and it will be having the fresh data that is not hacked. Okay.
Only part I didn't have the validation,
Yeah.
how the other users will be validating. If, for example, buyer 555, he makes a transaction, and copies will go to other ledger holders. I mean account holders. So those guys validate means they have to, like, their computer will automatically validate. How that works?
Yeah, I am clearing the point. Actually, what happens for any blockchain network to work, there is a piece of software that is to be installed in each and every computer. Okay. The user will physically will not validate that that particular piece of software is running and up all the time. Those users have devoted their computers in the network to do this kind of validation. Now the question arises, why they will put their computer to do these kind of validations? What are they gaining out of it? If they are gaining something, then only they will do this, no? Like they are like purchasing a $1,000 computer and put it on a network to do the validation. Why they will do this? They will do this because they will get the money out of it. How they will get the money out of it, we will discuss later. But the mining part is there, like they generate the money out of it. Okay. Suppose they are able to validate 1,000 transactions in a day, then they will get some kind of money because they are doing some validation. There is a kind of logic behind the scenes of this blockchain.
Okay.
Okay.
Yeah,
So
that is where the concept. Okay.
yeah,
Okay.
that is the thing. And one more thing I want to point out here: why it takes 4 years. You might be you will see you will ask me why it takes 4 years. It will take 4 years because what they do, you see, the validation, I am saying the validation is done by each and every computer in the network. Suppose there are 1000 computers in a network. There is a single transaction that is to be validated. Okay. To validate a single transaction, it takes 4 years. Okay. I am telling you like that. To validate a transaction, it takes a 4 year for a single user. Okay. Because there is a kind of cryptography. The data is converted to cryptograph, and to deconvert that data takes around 4 years for a single user. But suppose that transaction is 4 years is the maximum time. Suppose the user is very lucky. There is here is a hit and trial system. They will put a random number and try to convert it. If it is not converted, they will again generate a random number, and using that random number, they will again, like it's a guessing a password. Getting my point? Suppose a password is very complex. I am saying that password, to break this password, the data, its transaction, the transaction is protected with the password, and it is then traversed to the network, and a challenge is given, break this password. Okay, suppose this on an average the breaking of the password takes 4 years, but there are around lakhs of the users who are together doing the validation. Out of those lakhs of the users, there might be 2 or 3 users who are very lucky. They will do that particular breakage of the password within 5 or 10 minutes. Okay, here what it is being done, that particular conversion or the password breaking is being done. It is not a kind of password breaking, it is like a hashing. That kind of hashing is being done by thousands of the users together. So it will take around 5 to 10 minutes, but that particular hashing is done only by a single user. That is the case with the hacker. There will be no 10,000s of the hacker at the same time to break a particular transaction. Getting the point? There will be 1, 2, 3, 4, a less number of hackers. They will be only doing the hacking because their power is very limited comparatively with all the other users who are honestly doing their work. The hackers' power is very less. That's why the hackers' work will be rejected, and they will not be able to do any kind of conversion, because it will take to do any conversion 4 years, and by that kind of 4 years, everybody will know that you have tried to do this kind of stuff before some years. Then that particular hacker will be blocked after that time. Okay, so it is like internals. Don't go that much in detail, but it's a kind of overall big picture I am giving to you. Okay, next. It is the last slide in our demo. After that, we will do a practical interactive session so that you will understand it, how it does. There are some facts I am telling you right now. In the blockchain, there are 5 to 6 points. First of all, a computer on the blockchain is called a node. It is like, typically it is called a node in the terminology because it is a peer-to-peer kind of system, and peer-to-peer system, any computer is called a node. The first block is called a genesis block. In a network, if a network is very new, a company has created a blockchain network. The point to be noted, any company can create a blockchain network. It is not necessary to add to an existing network. Like Citibank has implemented blockchain. So their blockchain is private blockchain. They have created a first block and they have started with that. So their blockchain network their first blockchain block is called the Genesis block, because it is address 0 and there is no any transaction in the Genesis block. Genesis block is like empty block, it has no any transaction, it is just a block to start the formality of creating a blockchain. Otherwise blockchain will not be created. After that Genesis block is created, the transactions will be added to another block and it will be added to that blockchain. Third point, since blockchain is decentralized, there is no any central server anywhere. Somebody asks you, suppose where is the central server, it means they are just testing you. There is no any central server. Blockchain is decentralized. Every computer that is a part, every node in fact is a server in itself, and when all the nodes are collected together, they form a kind of central server, like not the central server, they kind of form kind of network, and that network is collectively doing all the work. Fourth point, Bitcoin. Bitcoin is a cryptocurrency that is built based on the blockchain concept, and since then blockchain has become very popular. Bitcoin has actually used the blockchain concept firstly. In fact, the idea was to generate the Bitcoin cryptocurrency, and to generate the Bitcoin cryptocurrency, a kind of network or some computer concepts were needed, and the platform on which Bitcoin cryptocurrency is running, that platform was later on popular by the name blockchain. Blockchain was not like generated in terms of that somebody has invented blockchain. No, somebody has invented Bitcoin, but the network on which Bitcoin was running was later on popularized by the term blockchain, because every, like I have explained to you, every transaction is a part of a block, blocks are connected together like that. So because of this particular kind of nature, it has become very popular by the name blockchain. That's it. And once any transaction is stored in the blockchain, it cannot be modified. If anybody tries to modify it, then the other nodes will immediately reject it. Why? Because I have explained to you, the majority wins. Because a single copy is different, it will be immediately rejected. Your copy is different, we reject it. It is no longer be there in the network. If somebody does this kind of thing again and again, that particular node will also be